In this episode, we're going to understand how AI is affecting your central nervous system and what it means for you, the viewer. Let's say you come from a different country. You're going from Japan, for example, in Osaka, to London in England to see Big Ben. But the following happens. You understand where you're going when you're in Osaka because you've lived there for many, many years. You understand where the airport is, the nearest airport. You understand how to get there. But now you're faced, when coming into England, a difficult and more distinguished environment. For example, you go through and you go through your checkout, you go through customs, you go through all of that stuff, but you're faced at Heathrow to try and understand where you need to go to get to Big Ben. Now, when you're in Heathrow, there are multiple ways that you can do that. For example, you can go and use the Elizabeth line. You can go use the tube, for example, right? But being in a foreign country, you do not understand or know exactly where to go unless you pre-planned it before. So here's the problem. You go on your Claude, you go on Gemini, you go on all these different apps to try and understand where it is that you need to go. But in doing so, you're expecting a clear level of instruction to understand where it is that you need to go. Now, instead of going directly to Big Ben, you're stuck in Heathrow Terminal 2 instead of the 3 which you were in. What happens then? Well, what's happened in that entire interaction? If we look at that interaction, what we can understand is that there was a cognitive offloading process. So what does that mean in terms of the way in which it reshapes our brain? Well, let's go into the theory of neuroplasticity. Now, neuroplasticity is essentially utilizing all of the neurons in our brain to solve a problem. Or more precisely, you use it or you lose it. So what does that mean? It means that we put our faith into a technology or device in order to get us from A to B, but we've forgotten the underlying structure, which is to actually reason and solve the problem. Right? Our problem was to go from Heathrow to Big Ben. So what does that mean in terms of our cognition? It means that we are relying a little bit too much on AI to do certain things. For example, I built a system for YouTube uploads, but the problem with it was that it just didn't work. Right? So I use artificial intelligence. I then go back and say, right, okay, this is the problem which I'm stuck on. This is what I'm trying to create. This is what I want it to do. And when I'm doing all of that, what I noticed was something very interesting. I run out of credits, but when running out of credits, it's good. It's actually a good thing, because what I realized was the art wasn't creating the program using artificial intelligence. It was solving the problems with something like Dragonfly, right? Whereby it wasn't starting up. And that reignited my interest in coding. I was actually happy because I had the challenge. So in this case, it's the challenge itself which makes us more intuitive and more likely to overcome a similar or more circumstantial problem. So in terms of artificial intelligence and central nervous systems, what it means is that we grow through the challenge. Not the usage of technology or reliance on it, but the challenge itself. Think of it as, utilizing the hippocampus, which is our brain, right? The part of our brain that we use, right? Which gets bigger based upon challenges and things that we need to remember, right? But like a London taxi cab, for example, they would know all the routes of London without you looking at the GPS because they've done it so many times, right? That's the repetition factor. Some people might call that discipline, but not necessarily. It's just pattern recognition. Very, very interesting stuff. And there's another thing that I want to point out here in terms of neuroplasticity, right? Where we shape the way in which our brain is performing, in other words, right? Is something called the Donald Hebb effect, which is what we talked about with the neurons firing. So, what does that mean? It means we need to use our brain in order to solve problems, or we lose the ability to solve problems entirely, right? Because we're offloading from cognitive, we're offloading that cognitive ability, that cognition part, which psychologically is quite damaging, right? Because now we're relying on this system in order to solve problems. And it's worse than we originally thought, because when disruptive technologies come along, for example, we had the horse and cart going into the car, it was very beneficial for society. Why? Because it just improved the way in which we traveled around, meaning that the time was less. Now, if we go, for example, to the library, right? People say knowledge was free. Yes, of course it was, right? We had books. Books were very difficult to read in terms of being able to sit down with our thoughts and articulate them, reading and writing. Now, isn't that surprising that I talked about reading and writing here, right? Look at the grades that we have at the moment in terms of teaching, right? Reading grades going down, writing grades going down. Isn't that interesting? That we've built a technology where cognition in its very simple human form, reading, writing, spelling, being able to solve difficult mathematical problems, right? All the stuff that we took for granted is now being offloaded to machinery, which inherently has actually acted as a cache. Very interesting, right? So psychologically, it leads us to numbness, because there's no creativity in what we are now doing or perceiving to be done, because the difficulty level, the barrier to entry, has actually gone down, which is not a good thing. It actually means that we're not using our brain in the way that we're supposed to, or the way in which we're being wired to, right? When we think about it. In fact, if the channel does actually get big, let's go and tag Andrew Huberman to get that information and understand what AI is doing to us psychologically, right? From a human perspective. Because it'll be very, very interesting to see what is the damage being done to us on a human level, right? We look at data centers, for example, which are being built all the time through different companies, releasing PM2 particles because of gas turbines, right? In fact, one infamous billionaire has already done this, and we're seeing increases in asthma at the moment, which is really, really, really bad for the environment, right? Environmentally, carcinogenic substances being released, and as a result, people are getting sick. Not a good thing at all. So, what's the takeaway here? Well, with cognition, reading, writing, and articulation are going to become more important than ever. So, the takeaway here is, to increase your neuroplasticity, you need to increase your curiosity in a certain subject so that AI becomes symbiotic with your reasoning. Not to reason for you. There's a difference. There's a difference, right? So what I mean by symbiotic relationship is that your curiosity in terms of a certain subject that you want to see or express has to be such that it is articulated through AI. Not that it does all the thinking for you to build something. Now, you could do that, for example, if you have no interest in the thing at all, right? Be it front-end development because you're a back-end developer. Perhaps it's back-end development because of front-end development problems. Yes, okay, AI is built so that way you can find that sort of thing out and experiment, which is very, very great. But you fundamentally lose the ability to reason what was in the code in the first place, which was the whole bloody point. Yes? Right? Because if you didn't know what was in the code in the first place, then how do you know what you're committing, right, if you're doing coding, is going to work? You don't unless you test it, right? And that's the thing. This is why we see all these companies at the moment struggling, right? Imagine that, right? We've had NVIDIA drivers just recently right? If you're in the tech industry, so to put that into perspective, this is the stuff which you download onto your system to keep it up to date, right? Make sure that the fans are working, the graphics that you see on the screen is being seen correctly, right? All that kind of stuff. Now, this is also the sort of thing that when you download for your games to work, right, is the core thing that you would download called the driver, yeah? So when you do that, and then all of a sudden, you know, it stops working because it was something called a vibe-coded application, which means that it was created using AI and therefore introduced even code which was not tested, not validated, we end up with a lot of problems. And this is what I'm talking about with neuroplasticity, that it's a symbiotic relationship in which the subject of choice is there to extract information in which you reason and you come to a logical decision. It is very, very important, right? That's the correct usage of AI. Symbiotic relationships. So, although you have the convenience to copy and paste, to scroll through the information, to create the dopamine reward circuit, which is we are looking at the information but getting it very, very quickly, right? Because of the tokens being generated per second, right? So the stuff that's being output by the AI itself, right? Think Claude, GPT, or, you know, even Gemini or GLM, Quen, whatever it is that you want to refer to, right? All of these things being output per second is actually increasing our dopamine level, right? And this is where we need to slow down. We absolutely must slow down. In fact, just recently, I was reading Crush It by Gary Vaynerchuk, right? This is an interest of mine. And in fact, I encourage anybody who's watching this particular video to take a step back from AI. Don't let the companies dictate what your brain should be doing, right? That's your job. You, the individual watching this video, right? You are in charge of your brain. Why do you want other people to tell you what to do with it? That is madness. And this is why I get so afraid with AI, because the one part that I can see for humanity is that, well, okay, we have this great, great tool, right? Artificial intelligence, where we consolidate knowledge and we can put it into our brain at such a speed that a lot of us can't actually interpret the information because there's so much of it available. It's an abundance of information, which is absolutely fantastic. But at the same time, it is worrying because our cognition goes down. Our ability to reason is being disrupted, which can strike fear into an individual because their central nervous system can be heightened even, and hyper because of the dopaminergic circuits which are being activated. So a couple of references for you, right, is Donald Hebb even, for Hebman learning, which we talked about in terms of the neuroplasticity reference there. So use it or lose it, basically, is what that describes. We've got Nature for neuroplasticity research. And the article here is Nature is just a leading thing. I've just got it up here at the moment, but that's nothing to be concerned about. And we have PubMed, right, for cognitive offloading. And that's where all the studies are coming from at the moment. So I will leave those down in the description once I can get reference to them. But essentially what I'm saying is, don't let anybody but yourself do the thinking, right? Don't let AI do it. Don't let ChatGPT do it, right? Because the problem with them is that going further into the conversation, they hallucinate. They have something called a context window. And a context window is essentially what you put into the AI in order for it to understand the data which you're feeding it. So think of it. In fact, let me show you. It's easier. So you see all this information here, right? This is called a context, right? This is where I put in like blah, 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 blah. Okay? That's called a context, right? But if we look at previous conversations which have been what's called compacted, right, which is all this information here, that refers to the last information that it understands in the previous window. So what do I mean by that? What that means is you have a conversation, right, with a peer, but you can only remember so much of the information. Now, I could write down that information, which is what Claude is doing in the background. It's writing down all that information and saying, these are the key points that I think are relevant to the conversation. And this is when we see, in terms of AI, something called inference, inferring data. Now, when we do an inference of the information, in other words, an inferring of the data, which is being fed to us, we make assumptions. And this is exactly what the AI is doing. It's assuming what you are telling it to do. It's assuming, not giving you the information that you seek, but assuming the information in which you seek based upon known patterns. Now, this is what in AI language is called the decision, or more precisely, the decision matrix, whereby a weight is allocated to a certain decision based upon the probability of the output being correct. So what does that mean? Think about it like flipping a coin. You have heads and tails, right? Two outputs. Now the AI would be trained on both heads and tails depending on the output and the number of coins. Now the probability of getting heads or tails depends on how many coins you have, which describe the number of possibilities which you can have in terms of getting a heads or tails, depending on how many you have, right? But notice that it's much more difficult to calculate amongst 10 coins than it is 2 coins or 1 coin. And that's what's happening inside of the AI, right? It's not a black box, as people call it. It's probability. It's just numbers being ran against what is being cataloged in terms of the system. Now, I find it a bit hard to believe that they call it a black box, because I think that there are ways in which you can decipher what's in it. And I think it requires a bit of logic. But nowadays, we've kind of lost that ability because we've offloaded logic. So the key takeaways that I want you to kind of understand in this video, before we wrap up. Struggle with the task for 5 to 10 minutes. Whatever it is that you're trying to do, don't cognitively offload it straight away. You don't need to. For 5 or 10 minutes, sit with the problem. Try to understand what the problem is telling you, right? If it's coding, for example, try to understand what the logs are telling you. Try to understand what the output is telling you, right? Perhaps read a book for 5 or 10 minutes to try and find a bit of information that you're missing in your research. Ask AI to challenge the answer from you, yeah? To get you to think cognitively, yeah? Summarize the outputs in your own words. I think that's quite an important one, right? Writing down, articulating the data will make it stick in your mind a lot better and stop that dopaminergic circuit that we are trying to avoid with AI. And then use AI to expand upon that answer, give you what you want, right? For when you are doing research-based tasks. Research-based tasks. And of course, schedule time away from the AI so that way you don't overuse it, right? And that will allow your cognitive brain, right, to slow down, essentially, and give you that relief that you're so much wanting. Yeah? So when we do those things, we're slowing down the rate of information, taking a breath, right? And trying to tackle a problem intellectually like it were a math equation. And that's, I think, is important, because what I find with that is that we actually appreciate the challenge more. And with AI, I think what's happening at the moment is that we're not appreciating the challenges that come as a struggle in our lives, because we are offloading this challenge onto a machine that has no context around who we are as people. Isn't that so interesting? We live in such an interconnected world that we negate our challenges onto what we believe is a sentient being, a sentient system, only to find out that it absolutely fails in one of the core things, in one of the core beliefs of what it means to be human, which is adaptation through struggle. Isn't that interesting? Anyway, I hope you've enjoyed today's session on central nervous system attribution with artificial intelligence. If it's been useful for you, please click like and subscribe to this channel, and I hope to see you again in the next one. Appreciate it.